Mass defect is one of the most interesting and curious phenomena in the universe. Particle collisions experiments, nuclear fissions, nuclear fusions, supernovae explosions, neutron star collisions, black hole collisions, etc., create mass defects. When a mass defect happens, it imparts kinetic energies to the products and product fragments, and heat and radiations are produced when the products hit the surrounding particles of matter. Here the important question is, how does a reaction or collision event create a mass defect? Now let's discuss one of the simplest fusion and fission reactions and the mass defect and mass gain associated with them. A free individual proton has a definite volume, density, and mass at rest. Similarly, at rest, a free individual neutron has a definite volume, density, and mass. But these particles reduce their volumes and masses when the two combine to form a deuterium nucleus. In other words, the volume and mass of deuterium are less than the total volume and mass of a proton and a neutron. But the density of particles remains unchanged. This tells us something significant. Here, when the particles are bonded together, they overlap each other too. Since the densities of the particles remain unchanged when they overlap, they must release the overlapped volume of mass. In fact, this causes the mass defect. We saw earlier that a mass defect does not directly produce photons, but only imparts kinetic energy to the products. It, therefore, leads to the conclusion that when a mass defect occurs, the missing matter is ejected and becomes a very thin, very fine state of matter, and this burst of matter provides kinetic energy to the newly formed deuterium. In other words, due to the mass defect, deuterium acts as a projectile with a large amount of kinetic energy and hits the surrounding matter particles, resulting in the production of heat and radiation. Now let's think about splitting deuterium into proton and neutron. When a deuterium nucleus splits, the proton and neutron regain their original volume and mass. But here also the density of particles remains unchanged. Here, because the density of the particles remains unchanged, the particles must absorb matter from space to regain their original volume and mass. Since this is an endothermic reaction, the energy applied to split the deuterium actually acts to absorb matter from space. These fusion and fission reactions actually clearly show how ordinary matter transforms into a superfine form of matter and how it transforms back into ordinary matter. It had been believed since ancient times that a form of matter or substance fills space. They called it ether. Therefore, I would like to call the above stated matter the same ether. Footnote: I doubt the accuracy of the standard model of particle physics. I think there is something wrong with this way of thinking. According to current understanding, a proton contains 2 up quarks and 1 down quark, and a neutron contains 1 up quark and 2 down quarks. Modern calculations show that the up quark weighs about 0.214% of the proton's mass and the down quark weighs 0.510% of the proton's mass. Here, since protons and neutrons share roughly the same mass, we can talk about a proton. So the total mass of the 3 quarks contributes only a fraction of the mass of a proton. If that is the case, then from where does a proton get its mass? According to the current belief, the quarks in a proton are moving very fast and at the same time, they are tightly bound to each other too. It means that the quarks in a proton have a great amount of kinetic and potential energies. According to Einstein's mass-energy equivalence theory, mass and energy are different manifestations of the same thing. So, this tells us that the kinetic and potential energies of the quarks contribute to most of the proton's mass. But we saw earlier that a mass defect does not directly produce photons, it only imparts kinetic energy to the products. Hence, matter-energy equivalence does not hold. Also, there is no evidence for the fast motion of quarks in the proton. In fact, it is only a hypothesis. So I think of the possibility that a proton consists of 3 quarks and a large amount of compressed ether, which contributes to the bulk of the proton's mass. So when a proton and a neutron combine to form deuterium, they release the overlap volume of the ether and release the potential energy associated with the compressed ether. When deuterium splits into a proton and a neutron, they absorb ether from space and regain their lost mass and volume. When particles collide in a particle accelerator, they almost completely collapse, releasing all the ether. This shoots all the product particles in different directions. Sometimes, if the collision timings are synchronized together, the smaller particles can combine to form heavier particles. In summary, more studies are needed to gain a more precise knowledge of the internal structure of the particles.